I would like to introduce our presenter today to all the team members, that we have a great opportunity today to learn from an experienced gentleman who has covered a very touching topic of chilled truths. It means delta T is an item which has been, it's like an overlooked item. Uh, and at the end of the design, at the end of the construction, we always see the operational costs, and not only the operational costs, there are the problems of the design in as an end user. When I'm using a building, when I'm sitting in my office, when I'm sitting in my bedroom, when I'm sitting in my living room, the effect of this delta T is felt there. The comfort cooling is not achieved, and we keep spending a lot of money to make corrections on the delta T. So there are a huge number of buildings presently in UAE facing this kind of issues and problems. So we do have here as engineers to note down how we can recorrect all our designs from the day one to avoid these delta T issues. We have with us engineer Syed Shah Hussain. He is an mechanical engineer working in Oshcorp Engineering Consultants, who is a very famous consultant. And Syed Shah Hussain also carries a loads of experience in HVAC design and execution and project management. He has also got recognition from CIBSE UK, especially for the energy performance. And we would like to hear from you, Shah Hussain, and now the table is for you to carry out the webinar. Thank you very much for joining us to the UAE MEP Engineers Group. Syed Shah Hussain, please proceed. Thank you.
Thank you, Engineer Wajid. Thank you for attending this, arranging this webinar. And yeah, as Engineer Wajid said, it's a very overlooked issue in current state of engineering. So let us start with this webinar. And good afternoon, everyone. I am Syed Shah Hussain. To give you a brief introduction, I'm a mechanical engineer. And we had a discussion before, generally in all of our projects that has been going on, was the truth of the chill water, that is delta T. The major issue in chill water is the delta T. It has been a hidden problem, one of the hidden problems that we have in the district cooling system. And sometimes due to this issue of low delta T, like delta T collapse or low delta T syndrome, the client or the tenant, whoever is residing in that particular apartment, has to pay higher bills. So let us explore the subject, and I'll try to explain this in as simple as possible, and I don't want to confuse everyone. So let's start with the subject. So the objective of the session is to make you understand what delta T means, why there are two types of delta T. So what are these two types of delta T? The major issue is low delta T, in which your return temperature is lower than what is expected. So why does this phenomenon occur? And why do these district cooling companies charge penalties when this low delta T syndrome occurs in your system or in your facility? And the reasons behind this. And I'll give you some few examples which I've worked before. I've come across low delta T syndrome in some of the projects that I've worked before. So I'll share with you an overview how we tackle this problem and how we resolved it. And I'll also try to explain the simple steps to prevent delta T collapse in your own building. So let's proceed. First of all, I'll explain you what does delta T exactly means. Okay. To explain you in simple terms, district cooling works like this. Cold water comes from the district cooling company. it enters your ETS, and from ETS to your building. ETS is energy transfer station. It's a room where your heat exchangers are there, and from there it will absorb the heat from your building. So basically, the chill water which is flowing in your secondary network in the building will absorb the heat from your building, and it will send back the warm water to the district building. Okay. The difference between the incoming cold water temperature and outgoing warm water temperature is called delta T. This is basically the simplest form we can put in delta T. Okay. I'll give you an example. Suppose the district cooling incoming water temperature is 6 degrees and your building is returning it back at 16. So the delta T would be 10 degrees. That means your building used the cold water properly. It absorbed enough heat. Okay. But in some cases, when these things go wrong, the district cooling, when we call it a low delta T, when the district cooling sends you 6 degrees, but instead of giving back 16, the temperature that is in the return line, it's 8 or 9 degrees, which is significantly lower than the required return temperature. This is called delta T collapse or low delta T syndrome. Okay. This basically it means that your building did not use the cold water properly. So what would be the reason? Let's explore this. I'll explain you first what is primary and secondary systems in the district cooling systems. Okay, district cooling plant. Primary side, district cooling side, that's what we call it. It's from the providers, Emicool, Tabreed, Empower, South Energy. Maybe it will be one of these in your one of the projects which you're working on. So the water that comes from these DC companies, district cooling companies, enters is directly, it will be going to a valve pit, and from there you are taking the time connection to your ETS room, that is energy transfer station room. From there, they will monitor their supply temperature, their return temperature, and the flow that you are consuming. That is the basis for them to measure the performance and bill you. Okay. Now, secondary side. What is the secondary side of district cooling? The secondary side, it's your building water. It flows to your AHUs, FCUs, absorb the heat from the room, returns warm chill water, goes back to ETS to exchange the heat, then returns to your building again. Okay, it's a loop. So most of your delta T problems happen in the secondary side, not on the primary side. Okay. So primary delta T is basically your district cooling side. Secondary delta T, it's your building side. Penalties, whatever happen, appear at the primary side. Okay, but the problem is almost always on your building side. This is a confusion that people usually get confused about. How does the secondary line, any problem in the secondary line will give us penalties on the primary delta T, that is DC side. So I'll continue. Let me explain this penalties thing in a very simple term. Like think of it like a DEVA network. Okay, you have a DEVA water meter at the, in front of your villa or apartment, whatever it is. And suppose you have some bathrooms in your villa, which you have opened half of it, not utilizing the full water supply. You have opened half of all of your taps, and the water keeps on running. DEVA will not go inside your villa and check all your taps. They won't know what you're doing with the fixtures. They will only see the meter, and they will bill you accordingly, how you have consumed it, what you are consuming. They will bill you like that. Same way the district cooling is. Okay, you are not utilizing the whole temperature which district cooling is providing to you. They will not see what you are doing with it inside your building, the secondary network. They will not advise you, they will not see that. So they will bill you according to what you're doing. That is what happens. That's how the penalties happen. So basically what happens is, let's proceed. I'll explain you step by step what happens. Imagine you're trying to cool a hot water drink with an example of a hot drink with ice. Okay, imagine you're trying to cool a hot drink with ice. You put ice in the drink, it absorbs all of the heat. The remaining ice becomes warmer and melts. This is like a good delta T. Now imagine your ice, it's touching only one small corner of the cup. Okay, to cool that hot liquid, it will take a lot of time because of the slow transfer of heat. So you add, even if you add more ice to it, to the corner of the cup, it will not help in cooling the liquid quickly. This is what exactly happens in the buildings too. Cold water enters your AHUs and FCUs. There are reasons due to which coil cannot absorb the heat. Maybe it will be design issue, maybe it will be installation issue, maybe it will be an operational issue. The water comes back almost as cold as it enters the coil. The room still, the room will still feel warm when this happens. The valve opens more and give more chill water. Due to this, what happens? The valve will open full and it will try to pump more water to the network so that the room gets colder. And this is a chain reaction. So this will go to the your differential pressure sensors and tells the pumps to increase the speed. And then again, the secondary flow increases. This will transfer the load to your primary side and the primary flow rises. What will district cooling supply, this management sees? Low return temperature, they will see high flow, they will see the low delta T. That's how they will issue you the penalties. Let me go to next slide. So usually what are the causes, root causes for this low delta T syndrome? It is defined into four issues that we usually have. First is the design issue. Second is the installation issues. Third is the commissioning. And fourth is the facility management. Okay. And I'll explain in detail about this in the next slides. Okay, let's explore the design issues that we have. Okay, usually what happens is during the design stage, if the coil for the units are designed over designed, means if the water is flowing and it's the coil is big and the water is less. So what happens is the heat absorption through the coil will not happen quickly. I mean efficiently. So your delta T drops in that reason, and sometimes due to the use of three-way valves and bypass coil is open, the water will circulate easily, and this will be also a reason of your delta T collapse. And if you're using low valve authority, weak valve cannot control the water properly, so too much water flows through the valves and not enough heat is absorbed. This also is a reason. And if you place your differential pressure sensor in the wrong place, usually I've seen this issue in many of the projects. So due to which, if you place it near to the pumps, it will think that it needs to run fast when it doesn't. Too much water is flown, and then the delta T collapses. This is also again a reason related to the design. And what are the installation issues that we face? These are the installation issues usually. Okay, like a real world scenario I'll explain you is air trapped inside the coils, strainer completely blocked with construction debris, FCUs connected backwards, insulation missing around the pipes, valves installed incorrectly, air vents missing at high points. These usually are the real world issues that we are facing now. And I have seen this kind of issues due to which the delta T collapsed. These are particularly related to the installation issues. And for the next slide, commissioning challenges that we face. These are the biggest causes, commissioning challenges. See, for any system to work properly, we have to commission them properly. So basically, when we are doing the commissioning, we have to make sure that the system is flushed properly, okay, to avoid these kind of debris, dirts, block the coil. Balancing to be done properly. If some valves are not balanced properly and some valves are open too much and closed too much, the water will not flow properly to the units, and that's also a reason that will cause the delta T collapse. Valves not turned properly, sensors are not calibrated, bypass line accidentally left open, HUs not tested. So these are the major things, that common mistakes and major mistakes that happens during the commissioning, which people usually tend to overlook, and which causes the delta T collapse. And of course, facility management also plays an important role in this. So even after the project is delivered, facility management takes over the project. They have to maintain the units by cleaning the filters. Valves, they have to maintain, they have to check. Sensors, they have to recalibrate after a certain period of time. They have to check if, when doing the maintenance, they should not keep the water bypass valves open even after the maintenance. These are the common issues for the FM team. They should have a overlook of this, so to avoid these kind of problems. So we did a project in Dubai long ago that we had a massive district cooling bill. The main concern, they did a re-verification of the system and everything. They found out that the delta T was low. But the client said to us, but the building is feeling cold. What's happening? Then we had a site survey. In this, we found out that 3 valves were there everywhere and was open. Some of them were not totally closed. It was partially open and the water was flowing. And strainers were full of construction dirt. They were not maintained properly. We found that the air was there in the risers. There was no air vent in the riser. And we found also that the sensors were not calibrated. They were showing the wrong readings. So that was the major issues. What we did was we cleaned all the strainers, we removed the air, we fixed the temperature controls, we fixed the sensors, calibrated sensors were replaced. And that's how we solved this issue. They initially, I remember, they had a delta T very less, like less than 10, 8 or 7 was there. And finally what they got was 16 or 15, I don't remember exactly, but yeah, they got a difference of 12 degrees, which was, and this reciprocated to their pumps, energy reduced by 32%. And district cooling penalty was removed completely for them. Okay. And now let's move on to the next slide. The same issue we faced in a retail complex in Abu Dhabi. We had one project where the tenants were complaining that the HU was sweating, high humidity, and yeah, the issue was that the filters were not clean, no discharge or temperature control was there, and there was this bypass valve. Again, we had an issue with the bypass valves, which were fully opened in this scenario, in this building, in this facility. And then we recalibrated, we did the same things. We did the flushing, we did the, we cleaned the filters for them, and we calibrated the sensors, which again brought back the delta T to the normal, and they were pardoned with the penalties were reduced for them, and the system was working great after that. So let's move on to the design solutions, what we can propose when we are doing the designing for the project. See, we can use PICVs or DRVs to control the water properly. The coil sizes should be correctly done and reviewed. and the DP sensors placed at the farthest point possible, so that it will sense properly and maintain the flow properly from the pumps. And no three-way valves. We should remove the three-way valves from the system. These are some of the recommendations that we have provided earlier for the design solutions related to improve the delta T performance for our network. And related to commissioning, we always recommend to flush system properly, clean the strainers before the testing and commissioning, balancing coils one by one, tune valves and pumps, calibrate the sensors. That's what we do, and close temporary bypasses fully. That's how we recommend usually to the people, to the clients, to not have collapse in the delta T or low delta T syndrome for the buildings. Operational solutions that we recommend is to maintain the room temperature at 22 to 24 and clean the filters. Every preventive maintenance we have with the facility management, it should be performed on time, instead of if they cause any delays, the filters will get dirt and the effective cooling will not happen inside the rooms. Again, the delta T will collapse. Recommissioning should be done every twice a year. Okay, and monitoring the delta T is one of the basic things that we have to do to keep it operational and working in the proper condition. So that's conclusion. I will conclude it by saying, let's summarize everything what we have listened so far. Low delta T, basically, what does it mean? It means wasting your chill water capacity, you're wasting the chill water temperatures. The problem is usually inside your building, not on the DC side. But what happens is, due to your problem is inside the building, it gets reflected to your ETS panels, and then what does DC see? That you're wasting the chill waters, low delta T syndrome. They see that the pumps have to run faster, they see that the temperature is not efficiently utilized, and they bill you accordingly. The basic problems that we see every now and then is the cause of the delta T problems are the dirty filters, wrong valves, what you can say, improper sizing of coils, and bad sensor placements. If you fix the delta T, it will improve the cooling, it will reduce your bills, and penalties is something we will not think about if the delta T is good. With proper design, commissioning, and FM, delta T can always be kept healthy. A healthy building always reciprocates to a low bill, good comfort, and efficient cooling. Thank you for dedicating your time today and listening to this. I have tried my best to explain you this syndrome in simplest terms possible. I don't want to go into very details of technical jargons, and it will be very difficult to understand if we go into that kind of technical detail. So I made it very short and I made it very simple. So if you want to connect with us, these are our, I do write articles, Engineer Vajid knows about it. My articles are into detail. So you can connect with me on this, and you can connect with UAE MVP Engineers Group, which I have known for a while now, and I appreciate what they are doing. They are letting everyone attend this kind of interactive sessions. So thank you, and I'll now hand over the session to Engineer Wajid. It was very nice session.
Thank you very much, Shaz Hussain, and we do have. We would like to be with you for some more time, because many of our members have a lot of questions to be done. So it's like a Q&A session for us, and maybe you can answer questions raised by other attendees, and we can benefit out of your knowledge. Though we have first question from Muhammad Mujahid Hussain. Muhammad Mujahid, thank you very much. I'll put up your question here. Uh, the question from Muhammad Mujahid is, when we design, select and install a system with delta T as 10 degrees, after installation or after a year, how can we increase the delta T to 12 or 14 degrees or more? So that's the question from Muhammad Mujahid.
Okay, Engineer Majid, if you don't mind, can we have this questions in a list? I have another session that I need to go. The client is waiting for me. I would like to answer these questions, and I will definitely answer it through UAE MEP engineers. But just I need some. I have somewhere to go to. If you can list out these questions for me, I'll be happy to answer them.
Okay, as our presenter is busy with some other commitments, prior commitments, we would like to say thank you to Mr. Syed Shaz Hussain. Whatever the questions are there, please put up. All the group webinar members can put up, and it will be answered through the UAE WhatsApp group.
Mr. Wajid, if Shaz is busy, let him leave. If we can answer the queries, let's have a quick interaction. Let's see who can answer his question. Can you put on the question? Let's see who can contribute.
Okay, Engineer Majid, I'll
Yeah, you can take a leave, Shaz.
Thank you, Jazakallah. Thank you, everyone. Thank you.
Let us see if any of the team members can contribute to his query. What is the query?
Sorry, may I know your good name, please?
This is Syed Wakil.
Okay, Syed Wakil, the question here is, when we design, select and install a system with a delta T of 10 degrees, after installation or after a year, how can we increase delta T to 12 degrees or 14 degrees or more?
No, you cannot increase. There is no way, because you have a base to design. So design is based on that equipment selection, and everything is based on that delta T. You cannot increase the delta T. From my point of view, there is no way, because when you design, there is a base, there is a benchmark to design. So according to that, you design the whole system, whole building. So from my point of view, I don't think so. We will be able to increase the delta T.
With us is a very senior gentleman, Muhammad Kaleem. Assalamu alaikum, Kaleem Saab, how are you? Okay, I think I would have to put forward the question here like this. See, gentleman, Muhammad Wakil, see, it's not like that. The question here from Muhammad Mujahid Hussain is, we have designed, selected and installed a system with a delta T of 10 degrees. It means the chiller is supplying X temperature and receiving Y temperature. The difference between the supply and return is 10 degrees. Okay, so now at the chiller point of view, I'm telling you, near the chiller header, it's going X and receiving Y. And the difference between these two is 10 degrees. That was the design. And now this is how it is performing. Let us say if I wish to increase this delta T from X to Z, where I can see the temperature practically giving 14 degrees for me. Is it possible? Yes, it is possible. We can always increase it. There are many ways to do that kind of alterations. Okay, we are not telling about the theory design.
Yeah, but what is the purpose of increasing? I need to understand why we need to increase the delta T, how it helps, because the system always varies. You will have varied delta T in the system all through the cycle. It's not constant that you will have delta T 10, you will have 11, 12, 14. It depends on the system, how the demand is, how the building demand is. So
we are in an ideal situation. The question is very simple here. If it is installed and it is performing at 10, can we increase it to 12, 14 or no? Yes, it is possible. That's the simple. Why we have to increase is a different question. The possibility is always there.
yeah, okay. So what's the how we can make it? Appreciate if we can share.
See, there are many factors depending on that one. The first thing is you can change the set points of the chillers. Set point, you can always change it. And when you change the set point of the chiller, on the other side of the terminals, they receive a different chill water temperature. And it means the coil temperature at your FCU and FAHU or AHU will be little lesser. Let us say I am supplying 6 degree. If I make the set point to 7 degrees, so definitely the terminal points will have will receive something, and they have to overwork, and then they will return the temperature at a higher temperature. This is number one. And number two is you can always play with the pressure handling units. And in the building, if you have got heat exchangers, there also you can play with the temperatures. And depending on the type of the building, type of the chill water network, and capacities of the machine, still there are also possibilities are there. We can always increase the temperature to 1 to 2 degrees, not more than that one.
Yeah,
What
here I
I'm
would also
trying to convey is the possibility is there. That's
if
why
you
what
would
is
allow.
happening, you know, for example, now a building which is working on Empower or Emicool or this district, any other district cooling plant, they send a notice to you. If you are not maintaining the delta T, they will send a notice to correct it. It means what? I mean, you have to correct the delta T. It means you have to always maintain the delta T. Whatever you have supplied, you have to use it and return it to them. So during what the building owners do, he goes back to the FM team, he goes back to the third parties to make a correction in his own system. And he does the chill water balancing. There are companies who do this kind of building surveys, and they correct the delta T and maintain it for the Emicool and Empower. Okay, we have one more question from Rahil Ahmed. How can we verify whether our air vents are functioning properly and ensure that there are no air particles present in the riser or pipeline system? Currently, the air vents are not releasing any air, and air separator is also not discharging air. However, when I drain, siphon or AHU chill water lines, the pressure gauge needle drops within 5 seconds, indicating a sudden change in pressure. What could be possible issues, malfunctions there? It's a very lengthy question, Rahil, and also very interesting question. See, in such scenarios, what will happen is you have to do a proper chill water balancing. Chill water balancing needs to be done, and once you do the terminal chill water balancing, you may be able to control the air releases, because it means, first of all, whatever it's the air with your situation, what you are saying is there is a possibility that the air vents are not placed at the right point as well. So we have to see the design. I mean, is the air vent placed in the right position? And okay, if it is placed in the right position, then has the chill water balancing been done properly? So these are the possibilities are there. When these two things are questioned, there is some more investigation is also needed on it. Because you know, I would like to convey to you one thing, that chill water systems theoretically are very easy. Theoretically, they look okay. It's very good. Chill water system means, number one, it lasts very long. You can be sure of getting the comfort temperature. but they come with a lot of problems. The problems come, which I want to convey to all the group members is, number one, the chiller supplier is different, the pump supplier is different, the AHU supplier is different, and there is a building management system, he is different. These four things has to be integrated. And fifth point is, you have a different installer as well. Somebody else is installing the chill water pipes. So any contractor or any company who is doing this air conditioning works, have they properly coordinated in all this system? Has the system been balanced properly? Because everybody raises his responsibility. Chiller will say, my chiller is working fine. The BMS will say, my controls are working fine. So these chill water systems are very tricky systems. In most of my projects, after a long research of doing projects for in the last 25 years, now I have started giving advice to all of my clients that wherever you can avoid chill water systems, please avoid it and go for the VRF systems. And okay, any more questions are there?
Assalamu alaikum, Mr. Wajid. Hello.
Gentlemen. Yes. Yeah, I'm hearing you.
Yes, the issue with the delta T, actually, I was just trying to access, but I couldn't access my microphone. So now I'm able to communicate with you. So the issue with the delta T, if the delta T is changed, all your selection, your piping, your fan coil unit AHU selection will change. So changing the delta T is a big challenge actually. Okay. If the delta T is more, your pipe sizes are to be reduced, otherwise the velocity will reduce and you end up with lot of issues. Okay. And conventional system should not be compared with the district cooling applications. District cooling application, mostly we have delta T 16. Conventional systems, we have delta T 10 or 12. So if you want to change the delta T, it means you are risking the entire system. The fan coil unit will not give you the performance. If you see the catalog from the suppliers, there is a separate selection for the delta T. If the delta T is changed, there is a separate series of selection. Separate models are available. So this is my input for this. Thank you so much.
I would like to clarify to you here, gentlemen, that the answer, the question was whether we can change delta T or not. The reply is yes, we can change it. What are the after effects? Why we have to change? Why should not change? That's a different question. And maybe and I have clarified that it is, if it is needed, where we have to see is any holistic figure. We cannot just go and change the delta T as for our convenience. Yes, you are right. I'm not denying that one. But sometimes it is where it is needed, we have to study and do this. Kalim Saab,
All right.
Assalamualaikum.
Wa alaikum salam rahmatullah. Please
How
continue,
are you,
sir.
Kalim? Yeah, I think
Good.
you have a question.
No, actually, I have replied on delta T. Thank you so much, Mr. Wajid. Thank you.
What's your response on it? Yeah. Okay. Do we have any more questions here, gentlemen? I think we do not have much questions from our colleagues here at this moment, and we do have a wonderful evening today, and we collected a we have made a very touch-based subject of delta T. So I would like to inform you that our next coming webinar will be in the month of December, and we do have a very interesting topic ahead with us coming up, and I would like to inform you in advance that this topic is a very important topic which covers the codes. UAE codes. So we have a very good presenter from MCube Engineering Consultants, who is going to present us this webinar in the next coming month, and he is going to cover all the UAE building codes for MEP engineers, how to do the compliance, what are the standards and best practices. This is Engineer Mohammed Murtuza will be with us from M3 Engineering Consultants. So I would like to inform you, all of you, that your participations are very much important at this webinar, and I would like to all of you to take benefit out of his vast experience. I know personally Engineer Mohammed Murtuza is a very good designer, and he has worked directly with the authorities in like Sharjah Civil Defense and Dubai Civil Defense, and even also DIVA and Dubai municipalities, sustainability and all these things. He has touched a lot of subjects, and he has also given authorized so many codes and everything, and he is a part of the ASHRAE member and co-chair at the ASHRAE UAE chapter. And I would like all of you to take a lot of benefit out of his vast experience, and inshallah you will all enjoy this next coming webinar. Thank you, gentlemen, for joining us. And I would like to also announce you through this webinar that our UAE MEP Engineers Group is going to collaborate with M3 Engineering Consultants, who are very specialized consultants for sustainability, energy improvement, building environment, and all these things. And in the near future, all of our webinars and knowledge base will be collaborated with them, and for the benefit of all the engineering community. I hope Engineer Mohammed Murtuza is with us today evening, or no, I don't think he's here with us.
I am there, Engineer Abdul Wajid. I am there.
Okay, Mohammed Murtuza, thank you very much, and we would like to see you in the next coming webinar, and would like to take a lot of benefit from your vast experience. Especially today's codes and practices are very important for us to understand and implement in all our design installations, and also after service installations. Thank you very much, gentlemen, and you will be receiving very soon all of your participation certificates.
Thank you very much. Thank you for this such a wonderful event. Thank you very much.